How do stars move in their orbits? Stars move in their orbits due to the gravitational force between them and the central object they orbit. In most cases, the central object is a massive body such as a black hole or a star, and the orbiting stars are typically much smaller in mass. The motion of stars in their orbits can be described by Kepler's laws of planetary motion, which apply to any objects orbiting a central body. Kepler's first law states that the orbit of a planet, or star, is an ellipse with the central body at one of the two foci of the ellipse. The second law states that a planet, or star, will sweep out equal areas in equal times as it orbits, which means that the speed of the planet, or star, varies as it moves along its elliptical path. Finally, Kepler's third law relates the period of a planet's, or star's, orbit to its distance from the central body. Stars in binary systems, where two stars orbit around the common center of mass, will follow a more complex path than a simple ellipse. The orbit will be shaped by the gravitational forces between the two stars, causing the stars to move in a more complex pattern. Overall, the movement of stars in their orbits is governed by the laws of gravity, which dictate the motion of objects in the universe. The specifics of the orbit will depend on the mass and distance of the central body and the orbital speed and direction of the star. What effect do the stars have on the Earth? Stars have a number of effects on Earth, both direct and indirect. Here are a few of the main ways in which stars impact our planet. Light and heat. Stars are the primary sources of light and heat in our solar system, and they play a critical role in the energy balance of Earth. The sun, for example, provides the energy needed to drive photosynthesis, which is the basis of most life on Earth. Tides. The gravitational pull of the moon and the sun creates tides on Earth, which have a variety of effects on the planet's ecosystems and coastal regions. Navigation. For centuries, sailors have used the positions of stars in the night sky to navigate across the oceans. Even today, satellites in orbit around the Earth rely on the positions of stars to maintain their orientation. Radiation. Stars emit a variety of forms of radiation, including light, ultraviolet radiation, X-rays, and gamma rays. While the Earth's atmosphere provides some protection from this radiation, it can still have harmful effects on living organisms. Cosmic rays. High-energy particles from distant stars can penetrate the Earth's atmosphere and impact the planet's climate and radiation levels. Inspiration. Finally, stars have had a profound impact on human culture and imagination, serving as symbols of hope, mystery, and exploration. The study of stars and their properties has driven scientific progress for centuries and continues to be a vibrant area of research today. Are earthquakes caused by stars? No, earthquakes are not caused by stars. Earthquakes are the result of the movement of tectonic plates, which make up the Earth's crust. The Earth's crust is made up of a series of large, solid plates that move and shift over time. These plates can collide with one another or move apart, causing earthquakes and other geological phenomena such as volcanic eruptions and mountain building. While stars do not directly cause earthquakes, they can have an indirect effect on the Earth's crust through their gravitational influence. The Moon, for example, exerts a gravitational force on the Earth that causes ocean tides to rise and fall. This gravitational force also causes small, periodic variations in the Earth's crust, known as Earth tides, which can cause slight changes in the stress and strain of the Earth's crust. In some cases, these small changes in stress and strain can contribute to the triggering of earthquakes, especially in regions where the Earth's crust is already under significant stress. However, it's important to note that the vast majority of earthquakes are caused by the movement of tectonic plates, and that the influence of stars on the Earth's crust is relatively minor in comparison. Can anyone go to the stars yet? At this time, no one can physically travel to the stars, as the distances involved are vast and our current technology is not advanced enough to make such a journey feasible. The closest star system to our own, Alpha Centauri, is about 4.37 light-years away, which means that even if we were able to travel at the speed of light, which we currently can't, it would still take more than 4 years to reach it. However, that being said, there are ongoing efforts to explore and study the stars using unmanned spacecraft and telescopes. For example, NASA's Parker Solar Probe is currently studying the Sun up close, while the Hubble Space Telescope and other observatories have provided unprecedented views of distant stars and galaxies. Additionally, there are plans for future missions, such as the James Webb Space Telescope and the upcoming Starshot project, which aims to develop a spacecraft that could travel at a significant fraction of the speed of light to reach the Alpha Centauri system. While we may not yet be able to physically travel to the stars, our ability to study and explore them through advanced technology and scientific research continues to expand our understanding of the universe and our place in it. Do stars break? Stars do not break in the way that a solid object can break or fracture. Stars are giant balls of hot, glowing gas, and their internal structure is held together by the force of gravity and the pressure of the gas within them. When a star runs out of fuel, it may eventually undergo a dramatic transformation, such as a supernova explosion or the collapse into a black hole, but this is not a result of the star breaking apart. That being said, stars can experience disruptions or changes in their structure and behavior due to a variety of factors. For example, a star's rotation can cause it to become distorted or elongated, and powerful magnetic fields within the star can create complex patterns of star spots and flares. In addition, interactions with other stars or gravitational influences from nearby objects can cause a star to be pulled out of its normal orbit or even ejected from a star cluster or galaxy. Overall, while stars do not break, in the traditional sense of the word, they can experience a variety of changes and disruptions over their lifetimes as they evolve and interact with their environment.